Now it's time to move on to one of the trickier sections, 10.5. 10.5 is going to use the chi-square distribution just like 9.4 did. So this is going to be a little bit dicey. So let's begin with the null hypothesis. So let's read the problem here. You can pause it while you read. But essentially what it wants is the null hypothesis is not P, not mu, but sigma. Hold on, insert. Make it bigger. There we go. Sigma. There he is. Okay. So what do we assume to be the rate for these lovely mutual funds that we're talking about here? And the answer is 4%. Let's read here, right there. See that? Less than 4%. Moderate risk is less than 4%. That's your alternative right there. Alternative is less than. So we need 0.04, right? 4%. We could just do 4. How about that? We'll make everything whole numbers. So 4%. Alpha is 0.05. There it is. Now we don't need this, but we do need sample size. So let me delete number of successes. That was from that. Sample size is N, which is 25 months. So we're looking at 25. Now what do we need? Now we need the standard deviation. Let me type this in here. STDV, which we all know is S, which is given to us in the problem. There it is. Standard deviation of the rate of return is computed to be 3.01. Great. Now another thing we're going to need is degrees of freedom. You don't have to find it separately if you don't want to, but in this case it might help because we have to do some funky things. So it's 24 in this case because it's sample size n minus 1. It doesn't really need to be separate. Okay, now we need to find our critical value. Okay, they're going to be, we want the low one because this is a left-tailed test. So we need the 1 minus alpha critical value. Okay, for the left-tailed it's 1 minus alpha. There, like magic, I came to the right page. Here it is, so you can see. It's a left-tailed test. See that? It says 1 minus alpha. I know it's really small, but it's 1 minus alpha. That's the chi-square. Looks like x squared, but chi-square 1 minus alpha. So we want a 1 minus alpha critical value. Now how to get it? Okay, well you get it with equals chi inverse 1 minus your alpha, which was 0.05, cell B2, comma, your degrees of freedom, but you figured that out already. It's in cell B5. Close your parentheses, enter. There's your critical value. Now notice it's not negative because the chi-square distribution, right, there's the 0. That vertical line, that's 0 in a chi-square distribution. So every chi-square value is positive because it's squared, right? Squaring turns things positive. Okay, so that's the critical value. Let me highlight it in yellow. There we go. Okay, next thing we're going to do is find the test statistic. So the chi-square statistic. That's going to follow a formula. The formula is equal to, oops, here, let me show it to you. There it is, right there. All right, n minus 1 times s squared over sigma naught squared. Sigma naught being the one that's in the null hypothesis. So it's equal to, let me move that, equal to n minus 1, but we already figured that, that's the degrees of freedom, cell B5, times, so times s squares, you got to do the caret 2, close your parentheses, divided by parentheses, sigma naught, so that's the 4, caret 2 again, because you got to square it, enter. Alright, there's your test statistic, right there. Now you can see, hopefully, this is not bigger than this, right? 13.59 is not past 13.84, right? So think about the picture. 13.84, right, is right here. 13.59 is over to the left. Since this is lower than this and we want a left-tailed, we're going to reject. All right, I'm going to show you how to find the p-value when we come back.